Hi guys, and welcome to the first revision lecture for 2018. So of course this is a revision lecture on SAC preparation for Area of Study 1. So in terms of the key details of the SAC, as I've said before, this will be happening on Monday, the 5th of March. Now, depending on what campus you are, we will be starting at different times. So Berwick, you'll be starting at 3:45 and you'll go to 5. And if you're at Keysborough, you'll start at 4 and you'll go to 5:15. If you are from Berwick, you will be doing the psychology SAC in the psych room, so 1.8. And Keysy kids, you will be in gym 1. The format of this test is a topic test. So there is going to be 15 multiple choice and 35 marks of written responses. So this should range from about 1 to 10 marks in terms of the length of questions. This is 50 marks and it is worth 8% of your total study score. In terms of the time allocation, you have 5 minutes reading time and 60 minutes writing time. Now that is a long SAC, it's the longest that we have in psychology this year, and as always I would suggest that you write relatively fast, just in case it takes you a bit of time to address certain questions. In terms of revision techniques, it's really important that you are finalising and ensuring that your summary notes are good to go based on the dot points. Now when you are creating your summary notes, they should not be an exact replica of your teacher's notes. What they should be is your representation and understanding of the content. So you need to make sure that you know the key terms, definitions, as well as things like examples, graphs, and more importantly, how to apply your knowledge to certain questions. The way that you can study for this is you can do a few things. So you can, and you should be, as a very first point, reading all of chapter 2 and 3, and you can access those on GoTo, or you should have the online textbook. After you've read through the textbook, you need to make sure that you are completing those summary notes. Now that can be in the form of a graphic organizer, it can be cue cards, or it can just be a word summary. What I would suggest you do is you make your summary notes and then you summarize it again into a mind map. But make sure that you are making those connections yourself, and that will really break down the key things that you need to know for this SAC. If you have some areas that you're not too good at, make sure you're doing the lot questions. Now, if you are bad at summary notes, I might suggest you just do all of the lot questions. However, if you have good summary notes, if you are confident in your content, you might just use these to spot check your knowledge and address areas that you really don't like. Once you've done your basic content revision and you feel confident with the content, you can do things like the end of chapter tests. You can do things like the hot questions and past exam questions without your notes. And what that's going to do is really test your understanding and knowledge of those questions. When you are done with your questions, make sure you email your teacher or touch base with your teacher so they can send you the answers or check over your responses, and then address your feedback by redoing those questions that you haven't done so well at, so you know exactly what you need to do to get the marks. Okay, let's get started by looking at the first dot points. Whenever you are making summary notes, it's really important that you know how to read and interpret the study design, because that's going to tell you exactly what you need to know for your exam. So for our dot point 1, we need to know the roles of different divisions of the nervous system, so central and peripheral nervous systems and their associated subdivisions, in responding to and integrating and coordinating with sensory stimuli received by the body. So we know that we need to know about the nervous system and the subdivisions, but what do we need to know? In the dot point says we need to know the roles of the nervous system in terms of responding, integrating and coordinating with sensory stimuli in the body. So what that's telling us is we don't necessarily need to know definitions, but what we do need to know is what each of these subsystems do and how they interact with each other in order to engage in everyday tasks. So we know that the nervous system obviously is firstly made up of the central nervous system here. So the central nervous system is made up of the brain and the spinal cord. Now the brain does a few things. It organises, integrates and interprets information. Now it does this through its connection with the spinal cord, which obviously connects the brain and the rest of the peripheral nervous system. Everything that's not the brain and the spinal cord is the peripheral nervous system. Now that carries messages to and from the central nervous system. Now we know that in terms of sensory information and motor information, sensory information goes up the body to the brain via sensory neurons, and that information is received, processed and integrated by the brain, and that brain will then initiate a response. Now motor neurons enacts that response, and that goes from the brain or the spinal cord down to the rest of the body. The peripheral nervous system is made up of two subdivisions. We have the somatic nervous system, and that will initiate voluntary motor movement, and what you should never forget is that there is a sensory role. So that is a part of the nervous system, or that's the division of the nervous system that will receive sensory information from sensory receptors. And of course it has that motor role in so much as it initiates voluntary motor movements. The complementary system to the somatic nervous system is your autonomic nervous system, and what that does is regulates those visceral muscles, organs and glands. So things like your heart rate, your stomach, all that kind of stuff. Again, we know that the autonomic nervous system is subdivided into the sympathetic and the parasympathetic nervous systems. Now, the sympathetic division of the nervous system activates the internal muscles, organs and glands to prepare for vigorous activity or to deal with a stressful or threatening situation. This occurs when the sympathetic nervous system is activated due to a threat or a stressor being perceived. So when that stressor is perceived, the sympathetic nervous system kicks in and it prepares the body for action to either run away, fight, or freeze. So we know that's a fight, flight, freeze response. Now the complementary system to the sympathetic nervous system is of course the parasympathetic nervous system. So that has a dual role. So in times of minimal stress, the parasympathetic nervous system helps maintain homeostasis, which is the steady, balanced state of normal functioning. So that's kind of when you're at baseline and everything is like functioning as it should be. That should generally be occurring most of the time. It's not super healthy for your body to be in a state of arousal for large periods of time, as we know through looking at the GAS model. When we are aroused, when we perceive there to be a threat, the parasympathetic nervous system will also counterbalance the sympathetic nervous system once the threat has passed. So what will happen is once you have overcome the stressor, the parasympathetic nervous system takes back over, again to resume homeostasis. In terms of a few tips and tricks, remember this dot point is all about how these nervous systems are integrated. The other thing that you should remember is that when in a SAC or an exam situation, you are never allowed to fully abbreviate. So we don't want to see things like CNS or SNS. What we want to see is something like somatic NS, autonomic NS, so on and so forth. Now our second dot point is about the distinction between conscious and unconscious responses by the nervous system to sensory stimuli, including the role of the spinal reflex. In terms of what this dot point is asking us to do, we need to know the distinction between conscious and unconscious processes, so we need to know what the differences are, and I would suggest you know that in terms of what those processes are, examples, and key characteristics. And you also need to know about the role of the spinal cord, so you should know the process, and why that occurs. We know that our nervous system responds to stimuli either consciously or unconsciously. In terms of the differences or the distinctions between these two responses, we know that a conscious response involves awareness, attention, and usually requires conscious control. What I would suggest is you don't use that word conscious because it's in the term, so you say involves awareness or attention. In directed comparison, an unconscious response involves no awareness or attention. Some good examples of a conscious response are things like feeling cold, so putting on a jumper, deciding to buy a handbag, picking up a bag of chips, having a sore stomach, so rubbing your tummy. Examples of unconscious responses are things like your pupils dilating, when you salivate at the smell of hot chips, or your heart beating. In terms of our key characteristics, you would use these to distinguish between one or the other. So a conscious response is voluntary, is goal-directed and purposeful. It tends to be more complex, so what that generally entails is a sequence of movements. And it can require learning, so we can learn to put on a jumper, for example. In direct comparison, an unconscious response is involuntary, unintentional, or reflexive. Most are simple, so they occur the same way in each time, and they generally only include one kind of sequence. Mostly these are innate, so they are inborn and they do not require learning. One thing to note when you're discussing distinctions or differences between concepts is that you need to make sure that you have a whereas statement, and you need to ensure that your differences match. For example, having awareness wouldn't necessarily match with an unconscious response being innate, so you would probably not get marks for that distinction because you need to ensure that those direct differences actually match in terms of the characteristic. So the next part of this dot point is the role of the spinal reflex. A spinal reflex is an unconscious, involuntary, and automatically occurring response to certain stimuli without any involvement of the brain. So, for example, when you jerk your bare foot up from hot pavement, or when you withdraw your hand if you touch like a needle or a hot plate, that's your example of a spinal reflex. You can also call this a reflex arc. And the reason it's called a reflex arc is because the spinal cord responds to the message directly before the message is actually received by the brain. Now, you should make sure that you know what the process is in terms of this spinal reflex. And you need to know that in response to the three different types of neurons. So sensory neurons, interneurons, and motor neurons. So let's have a look at this diagram. So this is an example of someone obviously touching a hot pan. So the first step is that sensory receptors, so we always start with sensory receptors in the hand, receive the pain message. Sensory neurons carry that sensory message along the pathway of the peripheral nervous system or the somatic nervous system, to be specific, up to the spinal cord. So once that message is in the spinal cord, interneurons in the spinal cord will relay the message to motor neurons. Motor neurons carry the motor message to hand muscles, causing a withdrawal reflex. And so, of course, then the Frank is released. Now, that three-step process is the unconscious part of this response, because of course that movement occurs with no interaction from the brain. Now, whilst that is happening, so while the spinal reflex occurs, sensory neurons also carry the sensory message up the spinal cord to the brain in the central nervous system. The message is received in the brain and processed, and it's interpreted as pain in the hand. And that last two steps they are the conscious aspect of this process. Now, the thing to remember is that this occurs to enable faster reaction time. And what that's going to do is that's going to increase survival by ensuring that the body part that is in danger will be in pain or in danger for the least amount of time. So when you're discussing processes like this, it's really, really important to ensure that your terminology is perfect. So we want to make sure that you're talking about the sensory messages and the sensory neurons, the interneurons and how they relay the message, the motor neurons and the motor messages. So make sure that you practice those kinds of responses and having that fantastic terminology. Okay, our third dot point is the role of the neuron, more specifically dendrites, axon, myelin sheath, and axon terminals, as a primary cell involved in the reception and transmission of information across the synapse. So those are the terms we need to know, but what do we need to know about them? We need to know the role. So we're more interested in what they do in terms of receiving and transmitting information within that neuron, okay? So this is about what's going on in the neuron. So it's really important to understand what each of the named structures do, but you need to know how they work together. Within the neuron, information is first received at the receptor site of the dendrites. Now that specifically is the postsynaptic neuron. The message is sent to the soma, around here, where the action potential or the neural impulse is generated. Now that electrical message, so let's remember it's electrical, travels along the axon and it reaches the axon terminal right at the end. Now, the speed of that transmission is helped along by the myelin sheath. The myelin sheath, as we know, is insulation to protect the axon and to also speed up the message. Now, once an electrical message gets to the axon terminal, it reaches sacs of neurotransmitter which are held in the synaptic knobs, and that action potential stimulates them to be secreted across the synaptic gap. In terms of the neuron, you need to make sure that you know that within the neuron, the message is electrical, okay? I would also advise you to be able to draw, label, and discuss the process of the message transmission within the neuron. So dot point number 4 is the role of neurotransmitters in the transmission of neuroinformation between neurons, so the lock and key process more specifically, to produce excitatory effects, as with glutamate, or inhibitory effects, as with GABA. In terms of what we need to know about this information, of course we need to know the role of the neurotransmitter in the transmission of information, and of course that's between neurons. When we're talking about information travelling between neurons, the first thing that you need to be aware of is the 3 parts that make up the synapse. First, we have the axon terminal of the presynaptic neuron. Now, you must make sure that you're saying the axon terminal of the presynaptic neuron, not the axon terminal, not just the presynaptic neuron, all of it. We have the synaptic gap or the synaptic cleft, and we have the dendrite of the postsynaptic neuron. Now remember that every neuron is both a presynaptic neuron and a postsynaptic neuron, depending, of course, where the part falls in relation to the synaptic gap or the cleft. So, once the electrical message or the neural impulse or action potential reaches the axon terminal of the presynaptic neuron, that will cause the neurotransmitters, so the chemicals, to be secreted from the terminal buttons into the synapse. Now those neurotransmitters will cross the gap or the cleft, and they are going to be picked up by the receptor sites of the dendrite, so these little things here, of the postsynaptic neuron. And then that process starts all over again. So in terms of the neuron, remember that we distinguish between two different types of messages. Within the neuron, so these structures here, that is an electrical message. If the message is chemical, or the neurotransmitters, that is between the neuron. So it's really important that you know the diagrams and that you know the specifics of how the messages are transmitted. Now, in terms of the neurotransmission process, so that chemical message, we are looking specifically at a process called the lock and key process. So we know that there are lots of different neurotransmitters and neurohormones in our body, and depending where they're secreted in the brain and by what receptor site they're taken up by, they actually have different roles. So that's why every neurotransmitter and neurohormone has a chemically distinct shape. So the neurotransmitter that has a chemically distinct shape, that is called our key. Once the neurotransmitter or the key bridges the gap, it will search for the receptor site on the dendritic spine that has a complementary shape. So like this one here, okay? Now that complementary shape is called the lock. Once the neurotransmitter finds the right receptor site, it binds to the lock or the receptor site, and it unlocks the postsynaptic neuron, okay? Now, if it's the wrong shape, like we see down here, this means the key will not fit into the lock, and so it cannot unlock the potential. As we said before, if the key unlocks the potential, then that will have either an excitatory or an inhibitory effect. In terms of an excitatory effect, now these definitions, excitatory and inhibitory, are ones that you should know relatively well. So what is an excitatory effect? Well, what this means is that this enhances the transmission of information by making the postsynaptic neuron more likely to fire, okay? So what happens is that that's going to continue the message down that postsynaptic neuron. An inhibitory effect means that the neuron is less likely to fire, so that action potential is less likely to be generated, and so the message will not continue in the postsynaptic neuron. In relation to excitatory or inhibitory effects, you need to know one example of a neurotransmitter for each. So of course, for an excitatory effects, we have glutamate as our example, and for inhibitory, we have GABA. It's not so important to know exactly what they do at this stage, but you just need to know that they are examples of excitatory and inhibitory effects respectively. The next dot point is dot point 5, the effects of chronic changes to the functioning of the nervous system due to interference to neurotransmitter function, illustrated by the role of dopamine in Parkinson's disease. Now, of course, you want to know about the role of the particular neurotransmitter, dopamine, and how that affects Parkinson's symptoms. So Parkinson's is an example of a neurodegenerative disease. Now that is a condition that results in progressive deterioration and death of neurons. So Parkinson's is a progressive degenerative disease that affects a person's control over their voluntary muscle movements, and that is a good phrase to be using when you're talking about the role of dopamine in Parkinson's symptoms, so voluntary muscle movements or voluntary motor movements. We know that Parkinson's is the second most common neurological disease in Australia and affects approximately 80,000 people in Australia. Parkinson's is idiopathic, so what that means is that there is no known cause. We don't know exactly what causes Parkinson's, but we do know there are risk factors, things like genetics, environmental factors, diet, age, and gender. More importantly, however, it's really important to understand the biological changes that occur and how that affects and links to the symptoms experienced in the disease. So essentially what happens is that motor symptoms, so things like tremors and things like that, result from the degeneration or loss of neurons in a place called the substantia nigra, which is just this little bit here. So it's located in the midbrain as part of the basal ganglia. Now that particular structure, the substantia nigra, has a role in the control of voluntary muscle movements so they can be executed in a smooth and coordinated manner. If there are fewer neurons in the substantia nigra, so if they die, it means that less dopamine is produced. So what we actually have is low levels of dopamine. And what that results in is the neurons firing uncontrollably, which means that a person who has Parkinson's cannot adequately control their voluntary motor movements. What that results in is those symptoms such as shaky hands and instability. So it's really important to understand what dopamine does. So it controls those motor movements, that there are lower levels of dopamine in Parkinson's, which results in neurons firing uncontrollably, and then we link that to those symptoms, more specifically the motions. It's really important not to get confused between motor and non-motor symptoms. So there are 4 key motor symptoms. We have tremor, which involves shaking of the body, muscle rigidity or stiff muscles, so muscles are unable to relax, slowness of voluntary muscle movement, and that's trouble when initiating movement and with repetitive movements, and postural instability, so that is the inability to maintain a steady upright posture. It's really important that you know all 4 of these motor symptoms and you know some non-motor symptoms too. So things like decreased sense of smell, sweating and increased sensitivity to temperatures, fatigue, which is not relieved by resting, mental health problems such as panic attacks, anxiety disorders and depression, and problems with cognitive functioning such as slowness of thinking, impaired planning, decision-making and memory loss. I would advise that you know all of the key motor symptoms, so know all 4 of these, and know at least 2 non-motor symptoms. In terms of treatment, we need to look at the dot point to kind of guide us in terms of what we should be talking about. Because this is talking about chronic changes to the functioning of neurotransmitters, we need to look at treatments that actually address the decrease in dopamine. Now remember, Parkinson's is idiopathic, so we cannot cure Parkinson's, but we can treat the symptoms. The way this is done is by medications such as L-Dopa, and what that does is mimic dopamine. Now more specifically, L-Dopa is an agonist. So remember, an agonist will mimic the action of the neurotransmitter, more specifically dopamine, that binds to the same receptor and it causes the postsynaptic neuron to fire. Our next dot point is dot point 6, sources of stress, eustress and distress, including daily pressures, life events, a culture of stress, major stress, and catastrophes that disrupt whole communities. In terms of this dot point, we're going to start with a few building blocks. So we need to know about stressor, stress, and stress reaction. So, a stressor is a stimuli that causes or produces stress and challenges our ability to cope. Anything can be a stressor, and they can be organised in different ways. So they can be positive and negative, physical, psychological, short-term or long-term, or high or low intensity. So, for example, a SAP is an example of a stressor. Breaking up with your boyfriend or girlfriend, going on a first date are all examples of stressors. A stressor will lead to stress, which is a physiological and psychological response to internal or external stresses that are perceived to challenge a person's ability to cope. Stress is considered a psychobiological process, and that's a really important term. What that means is that it's a combination of psychological factors and biological factors. And we look at those in terms of two models. So we look at it in terms of gas and in terms of the transactional model of stress and coping. There are some different types of stress. So we have acute stress, which is brief and specific to the demands of a particular situation. So acute stress tends to have very high arousal for a very short period of time. The other type of stress we have is chronic stress. Now that involves ongoing demands, pressures and worries that are long lasting. So that tends to produce high arousal for a long period of time. So acute is short and sharp, whereas chronic is prolonged. We can also subdivide stress into eustress and distress. And this particular concept is outlined by the dot points. And so it's really important that you know what eustress and distress is in relation to the definition, examples, characteristics. It would be wise that you know how to compare and contrast eustress and distress. So eustress is a positive psychological response to a stressor. This is generally indicated by positive psychological states, such as feeling motivated, excited, active, and alert. Eustress energizes us to meet the demands of a challenge, tends to be short term. So, for example, when you're feeling nervous before a big soccer game or a big sporting event, then you would probably be feeling eustress. You are feeling excited and active, and that's going to give you the resources you need to overcome that particular kind of challenge. Getting married or having a baby might also be considered eustress, because although it is stressful, you perceive it to be a challenge, so a good kind of stress. It's associated with excitement, things like that. In comparison, distress is a negative psychological response to a stressor. This is indicated by negative psychological reactions such as anger, anxiety, nervousness, irritability, or tension. Distress tends to impede our ability to perform or to cope. It can be short-term. So, for example, getting mugged is a good example of a distressing event that is short-term, or long-term, like a long-term illness, for example. The thing I want you to understand is that although eustress and distress are both kinds of psychological responses, and you need to reflect that in your definition, they both lead to, or they both initiate, the same biological or physiological response. So regardless of the type of stressor, the body undergoes the same physiological arousal. So for example, your sympathetic nervous system will be activated, your heart and respiration increases, your pupils dilate, and things like that, despite the fact the psychological states are different. So different psychological states, same biological arousal. Lastly, stress will lead to stress reactions. And so these include psychological stress reactions, and that includes your A, B, C, so affective behaviour cognitive. So things like poor concentration, loss of self-confidence for cognitive, anxiety, panic, fear for emotional or affective, changes in your sleeping or eating patterns, nervous twitches for behavioural. It also results in physiological stress reactions, so things like increased heart rate, things like dilated pupils, things like fatigue or chest pain or headaches. In terms of sources of stress, we also need to include daily pressures, life events, occulture stress, major stress, and catastrophes that disrupt whole communities. For these particular concepts, I would ensure that I know a few things. So I would ensure I know what the definitions are, examples, and your key characteristics, as well as how it contributes to stress. What you may be asked to do is compare and contrast these sources of stress to each other, or you may be asked to discuss them in relation to a wider scenario in conjunction with other kinds of concepts like gas or Lazarus or something like that. So daily pressures are minor troubles or concerns that arise in a day-to-day living that act as irritants, which annoy us and make us upset or angry. Some of these are common, but some can be rare. So things like having to clean your room, or missing the bus, or conflicts with a boyfriend or girlfriend, or not having enough leisure time, or losing things are all really good examples of daily pressures or hassles. The more hassles we experience, the more symptoms of physical, so things like headaches, and mental problems we are likely to experience. So individually, daily pressures aren't super significant, but they can build up and have a cumulative effect. So it's kind of like the straw that breaks the camel's back. So you might have lots of little things happening and then they all pile up until one more happens and you have a bit of a breakdown. A life event is a significant but relatively rare event that require a number of adjustments in behaviour within a short period of time. So things like changing schools, getting married, having a baby, going to jail are all examples of life events. They're not always negative, but they all involve adjustments. So whether it be getting married or going to jail, they both involve adjustments to your behaviour. The other thing to consider is that life events do involve choices. So this is different in comparison to, say, for example, a major stress or a daily pressure, which may not involve, or even a cultural stress, which may not actually involve a choice. A cultural stress is an example of a life event. And so this is stress that people experience in trying to adapt to a new culture when living in it for a considerable period of time. So when people move to a different culture or country, the more different it is to their original country or culture, the more difficulty they will experience. So things that they frequently encounter, things like language difficulties, racial discrimination, lower SES status, loneliness, homesickness, conflicts over preserving old values, and coming to terms with torture or murder of loved ones back home. A major stress is an event that is extraordinarily stressful or disturbing for most everybody involved. So being the victim of a crime, experiencing terrorism, or dealing with a terminal illness are all examples of major stress. Major stress can come in lots of different forms. So it can be a one-off event, so being the victim of a crime, being ongoing, so having an illness, and it doesn't necessarily have to be directly experienced. So, for example, if you witness someone getting mugged, that could still act as a major stress for you as the witness. Major stresses are psychologically traumatic, and so what that causes is adverse emotional reactions that may prevent proper functioning. So short-term effects include things like shock and denial, whereas long-term effects include things like flashbacks, strained relationships, unpredictable emotions, and sometimes a small proportion of people might develop mental illnesses, such as depression, PTSD, or anxiety. An example of a major stress is a catastrophe. So that's an example. So that is an unpredictable event that causes widespread damage or suffering. Now that can be natural, so something like a cyclone or a bushfire, or it can be attributable to humans, so things like terrorism. They tend to occur suddenly and they do disrupt whole communities, and it's completely out of those communities' control. The thing to consider with catastrophes is that survivors often experience a range of secondary stresses that compound stress and can contribute to a mental illness. So, for example, relocation as a result of homelessness, loss of employment, financial loss, physical injury are all additional stresses that actually make that initial stressor worse. Our next dot point is dot point 7. So we're looking at a model of stress as a biological process. So we're looking at Selye's general adaptation syndrome of alarm reaction, resistance and exhaustion, including the fight, flight, freeze response and the role of cortisol. So within this dot point, we need to understand Selye's gas as a biological process, and we need to understand the role of fight, flight, freeze response and of cortisol. The first thing that we need to understand is that the biological models of stress are non-specific. So what that means is that these changes occur in a similar way for all people. So for every single person, we should have relatively similar fight, flight, freeze responses and the model of gas. So let's start looking at the fight, flight, freeze response. This is an involuntary physical response to a sudden and immediate threat in readiness to confront the threat, escape it, or keep still and silent, avoiding detection. So this occurs when confronted by a perceived stressor. Now that stressor can be physical or psychological. So it could be an upcoming sack, it could be a football match, it could be going up and speaking in front of everybody at assembly. When we perceive there to be a threat, the sympathetic nervous system is activated and stress hormones, more specifically adrenaline, are released, which mobilizes our body to produce more energy and increase arousal levels. What this allows us to do is it gives our body more energy, or it increases our ability to successfully deal with a stressor and increases our chances of survival. So the fight, flight, freeze response is an adaptive response. In terms of the fight-flight response specifically, it's really important that you know at least 2 changes to the organs and how it helps the organism to survive. So, for example, our pupils dilate, that lets more light into the eye and enhances your vision so you can see more clearly when you're running away or you're fighting. When you're looking at scenarios using these kinds of elements, it's really important that you're applying really, really well to the scenario. So rather than saying enhances your vision to see a threat more clearly, tell us what the threat is. Running away from a murderer. When you're snowboarding, your pupils dilating lets more light into the eye so you can see the slopes better. While the freeze response is part of the same mechanism, there are some differences that you do need to know about. So when you are in a situation and you cannot run away or you cannot fight the threat, you activate the freeze response in order to survive. What happens here is, although the sympathetic nervous system is activated, the parasympathetic nervous system also becomes activated and it starts to dominate over the SNS. The reason for this is that our body needs to conserve energy in a mobilized state called tonic immobility, which is a state where body movements and vocalizations stop, the heart slows, blood pressure drops, and tense muscles collapse. This has an adaptive value because it allows the organism to stay undetected and it conserves energy until there's enough time to escape. So when the threat or the predator or whatever has been perceived to have been overcome, the sympathetic nervous system kind of switches back into gear, which allows the organism to run away, for example. You're most likely to see these kinds of examples of the freeze response in the animal kingdom. So a classic example is like the deer in the headlights. Or, for example, in my class, we looked at an opossum playing dead. We do also see this in humans, but it's, for example, you might exhibit the freeze response if you are suddenly needing to do a speech at assembly, or if you are asked a really hard question in an interview, or even if you are in a car crash and you need to conserve your energy in order to survive. So now let's look at gas in relation to the role of cortisol. In 1934, Hans Selye found that the body's stress response followed a predictable 3-stage pattern of physiological responses. He did this through experimentation on rats. So what he discovered is that gas or the experience of stress is non-specific and will occur whatever the source of the stressor. So he said that gas consists of 3 stages. We have alarm reaction, which includes 2 substages, shock and countershock, resistance and exhaustion. In terms of the gas model, there are a couple of things that you need to understand. So first and foremost, you should know how to draw this diagram that you see in front of you. For each stage, you should know the body's resistance to stress. So if it's above or below the line, you should know the biological or the physiological changes. And you should note any kinds of ailments that the person may experience in each stage. And that includes both psychological ailments or physiological ailments. In talking about the graph, it's really important to note that this line here is our line of resistance. Now that line differs from each person, and that's actually dependent on psychological factors. So let's start talking about these stages of gas. So when we first find out about the stressor, we go through the initial stage of gas, which is the alarm stage. This is subdivided into two substages. We have shock and countershock. So in shock, our ability to deal with a stressor dips below that line of resistance, and it makes it hard for us to cope with the stressor initially. Physiologically, the body acts as if it's injured, and our blood pressure and temperature drop. In this stage, fainting or heart attacks might occur. Now, in countershock, we can see that the resistance to stress is above the line, so we are actually coping. What has happened here is the sympathetic nervous system is activated, our arousal levels increase, and this is because the fight-flight response has been activated and adrenaline and cortisol has been released. So what's actually happening is our body is giving us energy or resources to deal with the stressor or to cope. In the resistance stage here, we can see that we are coping relatively well with the stressor. So the body's resistance to stress rises above normal, and we can see it's well above the line. But we can also see that resistance to stress is starting to decrease slightly just here, just above the end of resistance. Now, in resistance, we are coping with stress. So this is characterized by feeling, okay, we're getting there, we're able to cope. What's happening here is all unnecessary physiological processes are shut down, so things like digestion is shut down. Cortisol continues to be released to further energize the body and help repair any damage that may have occurred. Now, in the short term, cortisol energizing the body and repairing the body is a good thing. But that's only if the stressor is overcome relatively quickly and gas is kind of shut off. If that stressor persists, then we will continue to have cortisol being pumped into our body. Now, when that happens, our immune system activity is weakened because the cortisol levels are abnormally high. In terms of illnesses, this means our susceptibility to illness increases, and we are more likely to be getting things like colds, headaches, and coughs. Psychologically, towards the tail end of resistance, we have an increase in social withdrawal, and there might be an absence from work or school. In the final stages of gas, we are in exhaustion. So we're over here in this last stage. And in this stage, resistance to the stressor is well below normal. So it's well below this line, and the body cannot sustain the resistance. So what's happening here is that the body's resources have been depleted and the body is weak. And so what that means is that the body becomes much more vulnerable to physical and mental disorders. So physically, you're looking at things like heart disease, the flu, ulcers, obesity. Whereas psychologically, you're looking at things like extreme fatigue, high levels of anxiety, depression, nightmares, and impaired sexual performance. So in terms of the exhaustion stage here, the symptoms that we see are really, really extreme. It's also really important to understand the strengths and limitations of this model. I would recommend that you know 2 really good strengths and 2 really good limitations for the gas model. So in terms of the strengths, gas provides rich information about the physiological processes involved in stress. Selye established that the greater the stressor or the intensity, the greater the physiological response of the individual. He also established a strong connection between extreme or prolonged stress and certain diseases. And he showed that prolonged stress could lead to death in lab rats, and so his evidence was quite scientifically sound. In terms of limitations, there was an overemphasis on biological processes. So the psychological perspective of stress or evaluation of stress was not considered. The model was based on lab rats, so that's a problem because it means that we can't necessarily generalize to human participants. Our second last dot point is another model of stress. So now this time we're looking at the psychological process of stress. Now, a thing to remember is that stress is a psychobiological process. So what that means is the psychological aspects of stress and the biological aspects of stress actually interact in real life. And so it's really wise for you to understand how they combine and interact to affect each other from a day-to-day situation. In terms of psychological processes, we're looking at Richard Lazarus's and Susan Folkman's work in terms of the transactional model of stress and coping. More specifically, we're looking at the stages of primary and secondary appraisal. Now, this is a little bit harder than the nervous system or GAS, just because it's less specific and it's more open-ended, which might mean that you struggle a little bit with your structures. The thing to remember about the transactional model of stress and coping is that an individual's perception and assessment of a stressor is subjective. So what that means is we can all go in and experience the exact same stressor, but we will all perceive it differently, depending on a number of psychological factors such as personality, our general outlook on life, other pressures we have or past experiences. So it's really important that we know that psychological evaluations of stress are subjective, whereas the biological evaluations of stress or the processes of stress are non-specific. They're the same for everybody. So this model is divided into two appraisals, the primary appraisal and the secondary appraisal. And in this model, we give most of our emphasis to these things here, the primary appraisal. The primary appraisal is the initial evaluation process where the person determines the significance of the event. So they assess the situation and they ask themselves questions like, is this something I have to deal with? Am I in trouble? Is there any benefit to me? And they make a decision as to where the situation is stressful, irrelevant, or positive, benign. So if it's irrelevant, it means it doesn't really affect them. If it's benign, it might affect them, but there's no real reaction from it. If it's stressful, even a good kind of stress, it means it's affecting them and they need to do something to cope with that particular stress. If they appraise the situation as stressful, they will then assess the situation as either harm loss, threat, or challenge. So harm loss occurs when the harm has already been done or the damage has been done. So for example, if I've been fired, then I have lost my job, the damage has been done. A threat is an assessment of a harm loss that may not yet have occurred, but it could occur in the future. So I might lose my job that is damaged, but it hasn't happened yet. In contrast to those two negative appraisals, challenge is much more positive. So this is an assessment for the potential for positive gain from the situation. So I might hate my job and I might look forward to getting a job that I like more. So that would be a challenge. The thing to note about the primary appraisal is this tends to happen unconsciously and it happens in a split second. The secondary appraisal down here is where we evaluate our coping options and resources. So we look at resources that might be internal, so things like how healthy we are, our strength and determination, and external coping mechanisms such as money or support from family or friends. If we perceive that we have enough coping resources to deal with a stressor, whether it be harm, loss, threat, or challenge, then we might actually be experiencing more of a eustress, so we can deal with that stressor. If we feel like we don't have the coping resources to deal with a stressor, whatever kind it may be, that actually might result in distress. The thing to note about this particular model is that normally the questions are about justifying what kind of stressor the person might be perceiving the event to be. Now, generally, if they have perceived the event to be stressful, you need to ensure that you're identifying whether that stressful event is harm, loss, threat, or challenge, giving some keywords. So the damage has been done, there is future damage, there is an opportunity for gain, as well as giving a really nice example from the scenario. So in this model, your application is key. The other thing that's really important to remember is that stress is subjective. So again, if you're seeing questions and you maybe don't know where the extra mark is, you might consider Now again, it's really important that you know the strengths and limitations of Lazarus and Folkman's model. Again, I would expect you to know 2 strengths and 2 limitations. So in terms of strengths for this model, one good thing is that it focuses on psychological determinants of the stress response over which we have control. It emphasises the personal nature and individuality of the stress response, which Sally's model did not do. If you stress as an interaction with the environment in which the individual has an active role, explains why individuals respond in different ways to the same stressor, which is a good one. It allows for the fact that stresses and the circumstances under which they occur can change over time, and allows us to change our thinking about a stressor or our response. In contrast, the limitations are it's difficult to test through experimental research because of the subjective nature of the stressor, or the response to stressors, Individuals may not always be conscious or aware of the factors that cause them stress. We can experience a stress response without ever having thought about or appraised the situation. The model overlooks physiological responses. The linear approach to the model does not allow for individual variation in progression through its stages. The appraisers can interact with one another and are often undertaken simultaneously. And they are difficult to isolate for study for separate variables. So choose 2 of those that you understand and can talk more about. Our last dot point is about coping with stress. So we were looking specifically at context-specific effectiveness, coping flexibility, and use of particular strategies such as exercise, approach, and avoidance strategies. So this dot point is all about coping. Coping is a process involving cognitive and behavioural efforts to manage specific internal and/or external stresses that are appraised as exceeding the resources of the person. When we use a coping strategy, this is a specific method that is going to help us to reduce or manage the stress produced by any kind of stressor, regardless of what it is, regardless if it's physical or psychological. So these strategies are designed to overcome those feelings of tension associated with stresses. In this dot point, we are going to look at the effectiveness of coping strategies. Any kind of coping strategy can be influenced by factors such as the demands of the situation, one's ability to adapt and modify the strategy accordingly. What we're talking about here is both context-specific effectiveness and coping flexibility. Now, if we have those 2 things together, that will equate with an ability to cope effectively. What that means holistically is that people with good coping skills can evaluate which would be the best coping strategy for each situation and are able to change strategies if the need arises. Let's first look at context-specific effectiveness. So a coping strategy is considered to have this particular thing, so context-specific effectiveness, when there is a match between the coping strategy that is used and the stressful situation. So we must consider the stressor, the physical environment, and the individual involved in order for all of this to have context-specific effectiveness. For example, if you are stressed due to an exam, a strategy that might have context-specific effectiveness would be things like planning, time management, and study. because these kinds of strategies match the particular nature of the stressor, the environment, and the individual involved. If you, for example, didn't think about the SAC or the exam, then this might have less context-specific effectiveness because it actually doesn't have good fit or doesn't match that specific stressor. Now, this is combined with coping flexibility. Now, this is the degree to which a coping strategy or combination of strategies is successful in alleviating stress. This includes abilities to evaluate a coping strategy, modify an existing strategy, discontinue an effective coping strategy, or implement an alternate coping strategy if that actually is required. So this is all about the ability to effectively modify or adjust one's coping strategies according to different stressful situations. In real life, people with high coping flexibility, they tend to use a variety of strategies in different situations, and so therefore they tend to have a high level of context-specific effectiveness because they can quite aptly or they can quite easily look at a situation and figure out the one that best fits. And if that doesn't quite fit or it doesn't quite work, they can use an alternate strategy. When choosing a coping strategy, we might choose from either approach strategies or avoidance strategies. Now, depending on where and how you use each of these strategies, this will have a direct influence on your context-specific effectiveness and even your coping flexibility. It's really important that you know how to compare these two strategies. You know what they are, you know examples, and you know strengths and limitations of each of these methods. An approach strategy involves efforts to confront a stressor and deal directly with it. Now, this is when activity is focused towards the stressor, its causes, and a solution that will address the underlying problem and minimize or eliminate its impact. So, for example, if you failed a SAC, an approach strategy might be to sit down with your teacher and figure out how you might study better next time. If you need to get a job, then you might go to lots of different shops and hand in your resume. Strengths of the approach strategies is that it involves a change in behaviour and is viewed as a healthy way to deal with a stressor. It also allows the individual to feel in control of the situation, and it's a much more adaptive and effective approach than avoidance strategies. In comparison, the negatives may be that initially it may increase stress levels, whilst the individual is directly engaged with the stressor and its causes. What that might look like is, say for example, you go to your teacher and you say, well, I'm not studying for my psychology SAC as effectively as I might like. Can you give me some strategies? And they say, yeah, sure. You can do X, Y, Z. Now, when you're studying for the SAC, initially that's going to be stressful for you because you've got lots of things that you might need to do. But over time or in the long run, it's actually going to save you stress because you are dealing with the problem directly rather than just ignoring it. The other negative is that it may require a lot of the individual's energy, and that might result in them neglecting other aspects of their lives. In comparison, avoidance strategies involve efforts that evade a stressor and deal indirectly with it and its effects. So activity is focused away from the stressor, and there is no attempt to actively confront the stressor and its causes. So examples of that might be avoidance, wishful thinking, drug use, just kind of like ignoring the problem, drinking, overeating, things like that. Those kinds of strategies help to eliminate the feelings of stress, but they don't actually remove the stressor itself. Using avoidance strategies can be good because they might be necessary techniques so you can focus on stresses that you have the potential to change. So, for example, if you've already failed a SAC, then it's maybe not necessary or possible to focus on that stressor. So you ignore that stressor in favour of something that you can change, like your marks for another subject. It can be good for short-term relief, but if they're used for too long, they can actually prevent people from responding to stresses in a constructive way. The negatives of avoidance strategies are that they tend to be maladaptive, so they don't allow you to develop good coping skills. And so people who use these strategies are more likely to suffer from stress-related conditions like heart disease or ulcers. The last coping strategy that we're going to look at is exercise. So we all know what exercise is, but when you're looking at these dot points, it's really important that you know at least two changes that occur when you exercise and how that affects your well-being. So when you're discussing these, we want to see what the change is and what the effect is. So for example, when we exercise, this reduces stress hormone levels, so that's the change, and that reduces the experience of stress, which allows the immune system functioning to return to normal. So what's actually happening is you're returning to homeostasis faster, and that's the effect. That's how it benefits you. When you exercise, there is a release of endorphins, that's the change, and the effect is that reduces pain, stress levels, and it improves your mood. The thing to watch out for exercise is that there are both physiological and psychological benefits. So the release of endorphins is obviously a physiological benefit, but you might also have psychological benefits, such as it acts as a distraction or a timeout from a stressor.